In the previous demo, we created a deployment with two pods. Each pod has its own IP address. What is the IP address the end user should use to talk to the Hello World application? If the end user always uses one of the two IP addresses to talk to one of the pods, the other pod will remain idle and be underutilized. How to distribute the web requests from end user effectively between the two pods without asking the end user to remember all the pods and their IP addresses. What if the IP addresses of the pods change tomorrow? The solution to all these problems is to add a load balancer service on top of the pods. Whenever we have more than one instances of an application running, it is ideal to have a load balancer service added on top of them. In this picture, we have three pods that are connected to a load balancer service, which in turn is connected to the internet gateway. The load balancer will help distribute the web requests evenly between the three pods. All the three pods have been assigned with an internal private IP address, whereas the load balancer has been assigned with an external public IP address. A load balancer service provides a single interface or IP address at which any external agents could talk to these pods. The load balancer hides the IP addresses of the three pods underneath it from the end users. This is the basic principle of microservices architecture. With this little background, let's move on to our next topic, which is Kubernetes service. A Kubernetes service provides a service abstraction layer or a single interface through which the pods in a deployment can be accessed. Service abstraction layer contains a port, IP address, and a load balancer. Kubernetes service also does load balancing between the underlying pods. This is the service YAML file we will use for creating the Hello World service. The important fields in the YAML file are numbered to help identify them. Number 1, kind. It specifies the kind of the Kubernetes resource that we want to create. In this case, it is a service resource. External IP address. It specifies the external IP address of the load balancer. In our demo, this IP address is a private IP address of one of the worker nodes. Number 2, type. The type property is used to specify what type of service it is. In our case, it is a load balancer service. Number 3, port. It specifies the port at which the service gets requests. Number 4, protocol. The communication protocol used by the application. The HTTP server uses the TCP protocol. Number 5, target port. The port at which incoming requests are forwarded. Number 6 and 7, selector and labels. It specifies the labels to match. Pods that are labeled with app equal to hello world will be brought under the control of this service. Remember that this is the label we added to our pods when we created our deployment. Now, let's create the Hello World load balancer service using the service YAML file.